thank you for those kind remarks, and I want to most especially underscore all the thanks to all our multiple co-sponsors for making this happen, and thank you all for coming. As Francis mentioned, my task is to try to provide a little bit of context, some sort of template on which you can hang the information that you'll be learning over the next couple days. So the main question is, why law and neuroscience? Well, you may have noticed that suddenly brains are everywhere. They're in advertising, they're in magazines, they're in articles, newspapers. Even the president has jumped on board this train with a major brain initiative in which there's an effort to try to move our scientific understandings of the brain considerably further. Now, at the same time, there's been a proliferation of new disciplines, all of which love to use this word neuro right in the beginning. So there's neuropolitics and neuromarketing. There's even a field of neurohistory. There's a field very well developing right now in neuroeconomics. And of course, there's been what some have dubbed neurolaw. And the issue there that I want you to think about is, why is it that people think there may be some meaningful intersection between law and neuroscience? And a lot of people have been exploring the extent to which there may be advantages to be had in both the civil and the criminal justice system by incorporating selected insights from neuroscience. Of course, which insights to incorporate and how to do so are really the questions that we'll be focusing on both for the next couple days and also for many years to come. So why? Why do we think at the criminal justice intersection there may be things to explore at law and neuroscience as they come together? My own view is that the reason people are so excited about this, and I want to underscore, for better or for worse, I mean, over-enthusiasm is just as great a sin as over-skepticism. The reason people are enthusiastic about this, I think, is because there's this technicolor blossoming of hope at the intersection of the perennial questions that law is always trying to answer and the sense that there are new neurological, technological capabilities that will help to answer those questions. The kinds of questions we have in mind are the kinds that reveal that the legal system, particularly the criminal justice system, is in many ways obsessed with brains. A lot of the questions that we care about really devolve to questions about what's happening in someone else's head. So is this person responsible for his behavior? What was the person's mental state at the time of the offending act? How competent is the person? Is the person lying? What do they remember? How accurate is the memory? And how can we most effectively ensure the fairness of the decisions by third-party decision makers like judges and jurors? Okay. Now, against that backdrop of the perennial questions that we're always grappling with, we enter a world in which we've moved from thinking about the brain as some sort of bumpy lump of smart jello into which society merely pours this mind-bestowing elixir called culture, to a world in which we understand the brain to be increasingly functionally and anatomically specialized, with different regions of the brain all interconnected and operating in a degree of complexity that Jeff and others that we'll be talking about, but operating in ways that are non-randomly distributed throughout the landscape of the human brain. We've also moved from thinking about the brain as a function either of nature or in the complete dichotomous alternative of nurture, to a world in which we see brains as existing only at the intersections, the matrix-like intersections of genes and environments. And the third dimension here is, of course, evolutionary time. The brain has been shaped in the way it functions by long periods of evolutionary history that have tended, on average, to leave it adapted to associating various kinds of environmental inputs non-randomly with various kinds of behavioral outputs. It's flexible, it's complicated, it's subject to wide varieties in culture and environmental circumstances, and yet the way it operates is increasingly known to be a function of both genes, environments, and evolutionary processes over time. Technologically, and you'll hear more about this soon, but I want to just lay a little bit of a foundation for how we came to be where we are. We used to study the structure of brains on a slab. So cadaverous brain tissue that we would take apart. Gradually, technology has enabled us to do something rather remarkable, which was to take a live person and look inside the structure of their brain, first with things like X-rays, more recently with MRI. But there's only so far, as tremendous as that is, there's only so far that structural understanding can get you. It's like taking an X-ray of a laptop and trying to understand how it works. So what's really fascinating, what's creating the exuberance, sometimes the overexuberance to which we are all exposed, is the ability now, over the last couple decades, to increasingly study the function of brains, not just their structure, but the function of brains in live, awake people, non-invasively. That's as close to magic as anything that I've ever seen. It has its limits, and we're going to need to talk about those. But this, I think, is part of the explanation for why there is so much ferment at this particular intersection. So the hope leads to the view that maybe if you can scan a person's brain, you can learn something meaningful about how to adjudicate that person's liability and appropriate sentencing. And perhaps in civil contexts, you can learn not only about things relevant to tort actions, but also things relevant to disability benefit actions, which is where apparently a lot of the action is today. People bringing brain scans and neuroscientific testimony to say, I don't have a broken skull, but nonetheless, my brain tissue inside that skull is still not functioning as it should be. Give me my benefits. Okay, this has all led to a cascade of effects that I'll just mention very, very briefly. One is that for better or for worse, lawyers are increasingly proffering this information with characteristic warm zeal. Okay, a couple examples here. One is a case from 2010. This fellow on the left, Dr. Lawrence Semrau, was accused of Medicare and Medicaid fraud, one element of which was the intent to defraud the government, having not done so by accident. His attorney hired this fellow, a scientist at this company, Cephos, to put Dr. Semrau in an MRI machine and scan his brain for evidence of deception or truth-telling. And the idea was they wanted to introduce at trial this statement that Dr. Semrau's brain indicates he is telling the truth in regards to not cheating or defrauding the government 9 years ago. Okay, this is really a remarkable moment in legal history. And the magistrate judge who heard 16 hours of testimony in a Daubert-style hearing on this, which I had the opportunity to attend, really did a marvelous job concluding in the end that as of this moment anyway, it would be premature to allow this evidence to reach the jury. But I think it's a fascinating example of the ways in which lawyers are bringing neuroscientific evidence to your courtrooms and arguing that it should be admitted. Similarly, and again, for better or for worse, jurors are clearly being affected by this sort of testimony when it gets in. I'll give you one quick example. This fellow, Grady Nelson, sadly stabbed his ex-wife to her quick demise 67 times. He was quickly convicted of her murder. The question was, in Florida, a death penalty state, should he be executed or should he get life in prison without parole? The decision left to the jury, and in Florida this is a majority vote, not a unanimous vote. At the sentencing hearing, this fellow, Dr. Robert Thacker, introduced testimony similar to this, which is just a demonstration, so-called QEEG evidence, quantitative electroencephalography, to argue that this fellow, Grady Nelson, has a brain sufficiently broken, in essence, that it would be inappropriate to kill him, so let's just keep him in jail for the rest of his life. By the narrowest of possible margins, with his life literally hanging in the balance, the jury decided to give him life in prison, and 2 jurors came out afterwards and spoke to the press and said things similar to what one of the jurors is quoted saying here. The brain data turned my decision all the way around. I had been planning to vote to execute him, and instead the brain data convinced me that, and this is a direct quote, he had, quote, some kind of brain problem. Now, without speaking to the merits of that conclusion and the appropriateness of the inferences, it is fascinating to see that the evidence is brought into court and that for some jurors anyway it makes a difference. Not surprisingly, this tends to lead to an increase in offers of this sort of neuroscientific testimony. Third, judges and justices are increasingly citing neuroscience. Just one example about which you'll hear more later in the program is that the Supreme Court has on several occasions referred to neuroscientific evidence. Often this is brought in amicus briefs and query whether or not it makes a difference analytically to the resolutions of the cases. But what's significant at this point is that it's being offered to the court and that the judges and justices are citing it. Fourth, there's a broad societal interest in what can happen and should be happening at the law and neuroscience intersection. As one small sliver of evidence for that societal interest, I'll point to the accumulation of articles and books and chapters on law and neuroscience, suggesting, I think, pretty definitively that by 2015, every man, woman, and child in America will be writing in this area, so you might as well get used to it. But all of that writing is engaged right now in a hand-wringing exercise, ultimately, which is how are we going to grapple with this in the right way? How do we figure out what even the right way is? How do we navigate between the promise of the technology and the peril in either misunderstanding it or allowing people to misrepresent it or somehow misapplying it to the legal issues before us? How do we, that is, separate the wheat from the chaff? How are we going to approach that issue? How will we develop limits and standards for understanding the technology, for channeling its potential, and ensuring that we don't simply become handmaidens of science, simply rubber stamping conclusions that neuroscientists, for better or worse, paid by one side or the other, may be trying to encourage us to decide. So we need, that is, sober, I think, and very careful reflection where we pitch down the middle. You will not be hearing people in this curriculum say, neuroscience is so great, everything it says you should learn and do. We have to figure out where are the points of connection, the inflection points, where the neuroscience is not just interesting, but legally relevant to a particular decision before the justice system. How do we go about establishing a pathway for drawing legitimate inferences? And there, you will hear over the next couple days about chains of causal inferences that need to be drawn. How do you get from a feature in the brain to a particular behavior that a particular human did in a particular way on a particular day with a particular legal consequence? This is not a trivial matter, as you well know. So you'll be hearing about the abilities of the technologies, but you'll also be hearing just as important, if not more important, about the limits of the technologies so that we don't get the cart before the horse. It's easy enough to conclude that we're a long way from simply scanning people at the airport the way we scan baggage and realizing that Fred is planning to detonate the explosive toothpaste in his left breast pocket. Okay? We're a long way from that. We know that. And yet, we're faced with harder questions like this. This fellow is Herbert Weinstein, an otherwise unremarkable, calm, cool, collected individual who came home one day, strangled his wife, and threw her out the 12th story window of their apartment building. After he was apprehended, a scan of his brain, and this is the actual image that is often displayed, showed that he had a large subarachnoid cyst, that's a tumor in the lining of the brain, that was growing in such a way that it was squishing and compressing the rest of his brain in the zero-sum landscape of his cranium. Now, query whether or not that should have any relevance to his liability and any relevance, if he is held liable, to his sentencing. A lot of people to whom I show this image vote with their hands and say they would at least be willing to cut this guy some sort of inferential break at sentencing on the theory that he is just not rowing with all his oars in the water. Right? He is just not the same as the rest of us. But here's the problem. We really don't know enough about the rest of us. We don't know how many people are walking around with a similar tumor who don't throw their wives out the window. And without that sort of baseline understanding of the possible connection between this impingement on the frontal cortex of this individual, we don't really know what to do with that sort of information, and so it gets weighed in the balance alongside lots of other sorts of things. You may also be faced with hard questions where a lawyer may come in and make reference to group average data that's published somewhere. For example, this is a study of normal controls, the top row, schizophrenic individuals, and those with bipolar disorder. Okay, these are not individuals' scans, these are composites of group averaged scans and reflections of ways we can understand how their brains essentially talk to themselves at rest. And you will find somebody at some point is going to come in and say, Your Honor, I'm going to show you a brain scan that looks more like this one than it does like this one. And consequently, I just want you to infer that my client should be treated differently and should be considered mentally ill. And therefore, there should be legal consequences that flow from that that are more generous than they would be for normal controls. How do you move from group average data to the relevance, potentially, for a single individual? This is also not a trivial matter, and it's one that the research network has been spending a lot of time trying to address. So let me say just a few words about the research network and what we as a group are trying to accomplish, and then I'll move into the rest of today's program. So into this arena of complexity, criminal justice and neuroscience, the MacArthur Foundation moved about 6 years ago with some generous funding to two different programs, one first at the University of California, Santa Barbara, and another now headquartered here, to try to help the legal system grapple with the promise and the peril in a way that may keep us less far, not necessarily ahead, but less far behind developments as they are arriving in your courtrooms on a daily basis. We established the Research Network on Law and Neuroscience. We have a lot of resources available here on the website, including a searchable bibliography of over 1,000 articles on this subject. And let me mention that although the Research Network is headquartered here at Vanderbilt, it really exists in the collaborations of top flight scientists at top universities around the country with top legal scholars at top universities around the country, as well as with a number of terrific and influential and sharp and important judges who are helping us develop projects at this intersection, all in an effort collaboratively to pool the resources of these two disciplines to figure out how to first communicate with one another and then how to do projects that might move the ball forward. Those projects tend to fall into these four themes, having to do with development, mental states, evidence, and diffusion. And I'll just mention briefly that the foundation and its generous funding have enabled us to do not only conceptual projects, but also large-scale empirical ones involving scanning of a couple hundred adolescents across different age ranges to try to pull together for the first time under one umbrella a terrific psychological battery of tests to understand cognitive development as it relates to brain development, and to help us understand how these two things may be understood together more fruitfully than the two of them have been studied separately. And B.J. Casey is, along with Buffy Scott, leading that effort. Also, there are efforts at understanding how neurological techniques may help us learn more about the capacities and the limits for using these to detect deception. Anthony Wagner is here to talk also in that domain about using fMRI to detect signals of recognizing images that you may have seen previously. It's fascinating work, may have legal relevance, and it's all exploratory at this new frontier. There are also efforts that I and some others are undertaking to try to understand how you might be able to use these techniques to learn more about the fundamental brain activity underlying different forms of intent and different forms of assessing intent in other human beings, which is something that jurors and judges are frequently tasked to do. You'll be hearing more from me tomorrow about our research in understanding the brain circuitry and activity underlying deciding whether or not to punish someone, and if so, how much to punish them. We think that one of the exploratory ways this may be useful is in helping us learn enough about these decision-making processes to design behavioral training and interventions that might help us pursue the worthy goal of making decisions better, fairer, more effective, more just, and the like. We have an effort underway led by David Fagman with a lot of colleagues to try to understand how to move from the group average data to the individual level relevant to courts. And of course, most saliently for today, we've got an education and outreach arm that is engaged in diffusing this information and educating and opening up conversations to help educate us. So that brings me back to today's program. We have a terrific slate of absolutely top-notch presenters for you, with whom I'm very proud to be and humbled to be associated, and we'll be moving to that program in just a moment. But first, let me call out for special recognition Francis Shen, who, along with all the individuals who have been mentioned so far, has really put together a curriculum and executed on that in the most fantastic way so that we can bring this program to you and to others similarly situated. And I just want to thank Francis for everything he's done to keep this train on the tracks and on time. It's really been tremendous. With that, let me mention that with that, let me turn to introduce for a brief moment Dr. Jeff Aguirre, who is going to be speaking to you. He is an associate professor of neurology at the University of Pennsylvania, where he has both an MD and a PhD. I want to thank him for being here, in part because we have called on him repeatedly to try to do the impossible task of explaining everything about the brain and everything you might want to know about techniques for investigating the brain, and everything you might be worried about in terms of the limitations of those techniques for investigating the brain, in about 45 minutes to an hour with questions thereafter. So he has done this repeatedly and in fine effect. I don't want to suggest a bar so high that even he can't meet it, but I do want to say that he has just done such a fantastic job that I think you will appreciate, and your time attending to his lecture will be well worth it. And we're going to preserve some time that I will moderate for all your questions at the end, so please hold your questions and we'll have ample time to explore those. And with that, I ask Jeff to come up and begin. Thank you.